Welcome! In this lecture we consider some important statistical tests related to endogeneity. Given the standard model and instrument Z, there are two important things to test. First, whether the variables in Z actually qualify as instruments, and second, whether X is exogenous or endogenous. First, we focus on testing the validity of the instruments. Actually, we need to check three conditions. 1. We need to check whether there are enough instruments. 2. Whether the instruments are correlated enough with X. And 3. We need to check for zero correlation with epsilon. Checking the first is easy. We just need to count. If there are 3 endogenous variables, we need to obtain at least 3 additional instruments. To check the second, we can rely on the first stage regression of 2SLS. In this regression, we explain the endogenous variables using all the instruments. The additional instruments must sufficiently explain the endogenous variables. This is quite easy to check using t-statistics or an f-test. The final condition is more difficult to check. The testing procedure used for this is called the Sargent test. We will next look into the details of the tests for conditions 2 and 3. Let's first set up the notation. We split the explanatory variables into the endogenous variables in x1 and the exogenous variables in x2. The complete set of instruments is now formed by additional variables z star and the exogenous x2 variables. Remember that the exogenous variables x2 should be included in z. In the first stage of 2SLS regression, we explain x1 using z star and x. For 2SLS to work, we need that gamma 1 in the equation on the slide is unequal to 0. Now I would like you to think about why this condition is necessary. Please take some time to think about this. If gamma 1 is close to 0, the predicted values for x1 are almost perfectly correlated with x2. This complicates the second stage estimation and substantially inflates the variance of the estimator. In fact, if gamma 1 equals 0, the 2SLS estimator is not defined. To test for sufficient correlation, we can simply perform a T or F test for the null hypothesis that gamma 1 equals 0. Once you have established that instruments and the endogenous variables are correlated enough, you need to move on to test that Z is not correlated with the error term. The Sargent test can be used for this. The setup of the model and instruments is summarized on the slide, but it is the same as before. The null hypothesis in this test is that the instruments Z are not correlated with epsilon. We can rewrite this hypothesis in a regression that explains epsilon using Z. The null hypothesis that epsilon and Z are unrelated can now be translated to delta equal to 0. The problem that epsilon cannot be observed is solved by estimating its elements using 2SLS. To execute the Sargent test, we follow 4 steps. First, we use the instrument Z to perform 2SLS. Next, we obtain the residuals. Note that these residuals are based on X, not X hat. Next, we regress these residuals on Z and obtain the R squared of that regression. If the R squared is large, this means that we can explain a lot of the residuals using Z. This would be a sign that Z itself explains Y, and this would violate the assumptions. Therefore, we reject the null hypothesis if the R squared is too large. Under the null, the distribution of the number of observations times the R squared is approximately equal to a chi-squared distribution. The degrees of freedom equals the number of instruments, M, minus the number of explanatory variables, k. The degrees of freedom imply that the test can only be performed if m is larger than k. Please think about what happens in the case that m is exactly equal to k by answering this test question. If m is equal to k, 2SLS can still be applied and endogeneity is solved if all requirements are met. However, we just cannot test the validity of the instruments. Actually, with the Sargent test, we can only test whether the excess instruments are valid. We need to assume that at least the minimum number of instruments are valid. If the test rejects, we know that the set of instruments is not valid. Statistical tests cannot be used to figure out which specific instruments are invalid. In practice, you will need to also motivate the validity of instruments based on economic theory or logical reasoning. However, when in doubt about specific variables, the Sargent test is a very useful tool. After having checked the three conditions for validity of instruments, you can move on to the final hypothesis to test. The null hypothesis for this test is that particular explanatory variables are exogenous. This comes down to testing whether the entire 2SLS procedure is really necessary. The mostly used test is called the Hausman test. This test uses instruments to split the explanatory variable into two parts. One part is exogenous by construction, while the other part is endogenous under the alternative hypothesis. If the x variable is exogenous, both parts are exogenous and will have the same impact on y. If the variable is endogenous, this is not the case. The intuition of the test is to test for a difference between the two effects. We have the same setup for the Hausman test as before. For completeness, it is given on the slide. The null hypothesis is that the k1 variables in x1 are exogenous. The procedure of the Hausman test is as follows. First, regress y on x using OLS and calculate the residuals E. Next, obtain the potentially endogenous part of x1 as the residuals of a regression of x1 on the instruments. Call these residuals V. In the third step, we regress the residuals from step 1 on all explanatory variables and the residuals from step 2. If x is exogenous, V does not explain anything, and this regression should not fit well. If the R-squared is too large, we should reject the exogeneity of variables x1, and 2SLS is necessary. The distribution of n times R-squared is approximately a chi-squared distribution with as degrees of freedom the number of variables that we test. This was the last testing procedure related to endogeneity. In the next lecture, we will consider an application. But before that, I invite you to make the training exercise, to train yourself with the topics of this lecture. You can find this exercise on the website. And this concludes this lecture.